Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my name is Aulia Izza. My last digit number is 109. Okay, in here I will do my second project of Basic of Mathematics course. In here we will discuss about proof technique and then we will discuss about how to make conclusion. First, we will discuss about proof technique. There are four basic proof techniques. There are first direct proof or proof by construction, second proof by contradiction, third proof by induction, and fourth proof by contrapositive. First, direct proof or proof by construction. In a constructive proof, one attempts to demonstrate P implies Q directly. There are only two steps to a direct proof. First, assume that P is true. Second, use P to show that Q must be true. Second, proof by contradiction. The proof by contradiction is grounded in the fact that any proposition must be either true or false, but not both true and false at the same time. We arrive at a contradiction when we are able to demonstrate that a statement is both simultaneously true and false. Showing that our assumptions are inconsistent, we can use this demonstrate P implies Q by assuming both P and negation of Q is simultaneously true and deriving a contradiction. When we derive this contradiction, it means that one of our assumptions was untenable. Presumably, we have either assumed or already proved P to be true, so that finding a contradiction implies that negation of Q must be false. The method of proof by contradiction are: first step, we can assume that P is true. Second step, we can assume that negation of Q is true. And then third, use P and negation of Q is demonstrate a contradiction. Third, proof by induction. Proof by induction is a very powerful method in which we use recursion to demonstrate an infinite number of facts in a finite amount of space. The most basic form of mathematical induction is where we first create a propositional form whose truth is determined by an integer function. If we are able to show that the propositional form is true for some integer's value, then we may argue from that basis that the propositional form must be true for all integers. First step is show that a propositional form Px is true for some basis case. Second step is assume that Pn is true for some n and show that this implies Pn plus 1 is true. Third, then, by the principle of induction, the propositional form Px is true for all n greater or equal to the basis case. Fourth, proof by contrapositive. Proof by contrapositive is a method of proof which is not a method all its own pairs. From first order logic, we know that the implication P implies Q is equivalent to negation of Q implies negation of P. The second proposition is called the contrapositive of the first proposition by saying that the two propositions are equivalent, we mean that if one can prove P implies Q, then they have also proved negation of Q is implies negation P, and vice versa. Okay, we going to about example problems of basic proof technique. First, prove that if x is odd number, then x power 3 plus x plus 2 is divided by 4. From these problems, we get given x is odd number. By definition, we get x is equals to 2n plus 1 for n is element of integers number. We get x power 3 plus x plus 2. We can substitute that 2n plus 1 to x power 3 plus x plus 2. We get 2n plus 1 power 3 plus 2n plus 1 plus 2 is equals to 8n power 3 plus 12n squared plus 6n plus 1 and then plus 2n plus 1 and then plus 2. We get 8n power 3 plus 12n squared plus 8n plus 4. From 8n power 3 plus 12n squared plus 8n plus 4, we can get 4 times 2n power 3 plus 3n squared plus 2n plus 1. So we can conclude that if x is odd number, then x power 3 plus x plus 2 is divided by 4. Okay, second example problems. Prove that 9 power n minus 5 power n can be divided by 4. We will prove that 9 power n minus 5 power n is equals to 4b. Suppose that Pn is equals to 9 power n minus 5 power n. So the step is prove that P1 can be divided by 4 is true, and then P1 is equals to 9 power 1 minus 5 power 1 is equals to 4. As we know that 4 can be divided by 4, we can conclude that P1 can be divided by 4 is true. Assume that Pk is true for k element of n natural number. Pk is equals to 9 power k minus 5k is true. We assume that Pk is true, kan? Okay. And then prove that Pk plus 1 is true. We can substitute that that k plus 1 to Pn. So Pk plus 1 is equals to 9 power k plus 1 minus 5 power k plus 1 is equals to 9 times 9 power k minus 5 times 5 power k. Because we cannot change the question, we just can pass this function by 0. So because minus 5 times 9 power k plus 5 times 9 power k is equals to 0. So we get 9 times 9 power k minus 5 times 5 power k minus 5 times 9 power k plus 5 times 9 power k is equals to 4 times 9 power k plus 5 times 9 power k minus 5 times 5 power k is equals to 4 times 9 power k plus 5 times 9 power k minus 5 times power 5 times 5 power k is equals to, we get 4 times 9 power k plus 5 times 9 power k minus 5 power k. As we know that 9 power k minus 5 power k is equals to 4b. So we get 4 times 9 power k plus 5 times 4b. We get 4 times 9 power k plus 5b. From this form, 5 times 9 power k plus 5b, we can conclude that Pn is divided by 4 for every n element natural numbers. Okay, third example problems prove that if m is odd number, then m power 3 plus 2 is also odd number for m element of integers number. Then we will prove by contrapositive. First step, suppose that premise P state that m is odd number, Q state m power 3 plus 2 is also odd number for m element of integers number. We can denote P implies Q is equivalent to negation of Q implies negation of P. We will prove that negation of Q implies negation of P is true. Negation of Q states M is even number. Negation P states M power 3 plus 2 is even number. By definition, because M is even number, we get M is equals to 2n, and we can substitute 2n to m power 3 plus 2. We get 2n power 3 plus 2 is equals to 8n power 3 plus 2. We can change to be 2 times pn power 3 plus 1. We can conclude that if m is even number, m power 3 plus 2 is also even number for m element of integers number. So we can conclude that negation of Q implies negation of P is true. By contrapositive law, if negation of Q implies negation of P is true, then P implies Q is also true. So we can conclude that M is odd number, then M power 3 plus 2 is also odd number for M element of integers is true. Okay, the next we will discuss about conclusion. Okay, in how to make a conclusion, there is deduction method for formal proof of the validity of the argument. There are inference rules. First is modus ponens or MP. If there are two premises, first premise is P implies Q, and then second premise is P, so the conclusion is Q. Second is the modus tollens. There are two premises. First premise is P implies Q, and then second premise is Q, so the conclusion is P. The third is syllogism. First premise is P implies Q, and then second premise is Q implies R, so the conclusion is P implies R. The next is destructive syllogism. The first premise is P or Q, and then second premise is negation of P. So we get conclusion is Q. Okay, the next is constructive dilemma. We have first premise is P implies Q and R implies S. And then second premise is P or R. So we can conclude that the conclusion is Q or S. The next is destructive dilemma. First premise is P implies Q and R implies S. And then second premise is Q or S. So the conclusion is P or R. The next is simplification. The first premise, there is only one premise, P and Q, so the conclusion is P. The next is addition. There is only one premise, so the premise is P, and then the conclusion is P or Q. The last one is conjunction. There are two premises, P and Q, so the conclusion is P and Q. Then, example problems of the validity of the argument from the conclusion. If there is statement, if Danu goes to school, then Danu has breakfast. If Danu has breakfast, then Danu will be healthy. Today Danu goes to school, thus Danu will be healthy. Suppose P states Danu goes to school, Q states Danu has breakfast, R states Danu will be healthy. We get premise. First premise is P implies Q, second premise is Q implies R, and then third premise is P, so we can conclusion that R. Proof. P implies R from syllogism rules of premise 1 and premise 2. And then we get R from modus ponens premise 4 and 3. So we can conclude that statement "then will be healthy" is true. Okay, the second example problems. Prove the validity of the argument from the following conclusion. Mr. Ali is a trader or a farmer. If Mr. Ali is trader, then he is rich. It turns out that Mr. Ali is not rich, so Mr. Ali is a farmer. Suppose that P state Mr. Ali is a trader, Q state Mr. Ali is a farmer, R states Mr. Ali is rich. We can get the premise. First premise is P or Q. Second premise is P implies R. Third premise is negation of R, so we can conclusion that Q. The proof is negation P. We get negation P from modus tollens of premise 2 and premise 3. And then we get Q. We get Q from destructive syllogism of first premise and fourth premise. So we can conclude that statement Mr. Ali is a farmer is true. Okay, that's all from me. Sorry for any mistake. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.